Hi and welcome to this tutorial. In this series of videos we're going to build an Asteroids game using the Godot Engine. So for you that might not be familiar with the Godot Engine, it's kind of similar to like Unity and Unreal and those really big engines, except that it's completely open source. So this is the Godot Engine. You can see that we have a viewport here in the middle where we can see kind of a 3D scene. We have on the left side here our folder where all our game assets will be located. On the right side here we have the scene tree that's currently empty, but this is where all the entities that are currently loaded into the scene will be visible. And down here we have an inspector that we can control and configure different settings for each entity. So since we're making a 2D game, the first thing that we're going to do is switch over to 2D here, so that we don't see this 3D scene. Next we're going to create a root node for our scene. So some engines, they make this automatically, but in Godot Engine, scenes can be inherited and can be put into each other. So we have to manually create a root node. So in this case, I'm just going to create a simple node 2D, like this. We can call it game, because this will be the root of our entire game. And then a good thing to do when you created a new scene like this is to save it, because you can't save it until you have created your first node in it. So I'm just going to create scene and save scene as, and then call it game. Great. So now we can just press Ctrl S and save the game like you're used to. Next, we're going to go into the settings here and change a few things. So we're going to product settings, and here we're going to go down to display window. And for me that was the window that was already open. And then I'm going to go down here to stretch mode and change it from disabled into 2D. So this will tell Godot that we want the stretching of the screen to be like a regular 2D game. We can also go ahead while we're in here and go under application and then run and change the main scene to the file that we would just save, the game.tscn. That is the scene file of the Godot Engine. So then, when we launch the game, this scene is the one that will be loaded automatically. Great. So now if we save this and press the play button up here, you'll see that we have an empty window, but it's loaded our game correctly. So, let's add a few assets to the game. So in this folder here, I have downloaded a number of open assets from the web, and I will link to the authors of all of these. So first, let's create kind of a space background that will be the backdrop of the game. So under background here, I have the file Corona up here. So I'm going to create a folder in the game engine called background, just to keep the assets well organized. And then in here, I'm going to drag the Corona up and just drop it there. And it will be imported. Next, we can take this and we can just drag it into the game. You see that I now have a drag drop. So let's press it and go down under transform here on the inspector and change the position to 5 by 12, and then something like 300 is probably good. So this will center it on the screen, since our screen is exactly 1024 pixels wide. So now if we relaunch the game, you'll see that we have a space background here. We can even resize it and it will automatically scale to the window. That's the 2D setting that we did before. So I'm going to change the name of this node to background, just to keep everything well organized. And a good convention in Godot is to name all of the nodes with a capital letter first. So game with a large G and background with a capital B. Next, let's add an asteroid that can kind of fly around in this weightless state. So we go back into our roots and we create a folder called Asteroid. And in here, I have prepared an asset. It's basically the Space Meteors sprite from the Kenney open game assets. I'm going to drag it in there. But now, one thing we want to do. If I just drag this into the game here, we can see that it's kind of blurry here. And the reason for that is that the sprite is being filtered like a texture in a 3D game. And that's usually what you want if you are going to look at a texture up close. You want it to be a little bit blurry so that the viewers can't see the exact pixels. But in a 2D game, you usually want quite crisp pixels. So in this case, I'm going to go in under Import, and then I'm going to uncheck the filter here, and then re-import. So now we can see that I have crisp pixels here. Next, this is a very, very large asteroid, so I'm going to shrink it down a little bit. So I go down under Transform here, and change the scale to something like 0.2 by 0.2, 20% of what it was before. But still, this asteroid doesn't really do anything, it's just a sprite in the scene. So let's add some physics to it to make it fly around. So I'm going to go to the scene here. We can see that it created this under the background node. I'm going to move it up under the game node. And I'm going to change the name of this to something like sprite. Then I'm going to create a rigid body. So rigid body is one of the 3 possible physics nodes in the Godot engine. We can take a look at the physics body here. And we'll see that we have a kinematic body, a rigid body, and a static body. So basically, you want a static body when you have something that will never move. It will just sit there and other things can interact with it. So that's something like a tree. Then you have a rigid body. A rigid body is something that can be interacted with, like a box that somebody can push. But the rigid body is not, it doesn't move by itself. It is basically something that physics interact with, but the body can't move itself. And then you have a kinematic body. And a kinematic body is the opposite. It is something that moves by itself, and physics doesn't interact with it, but it can interact with physics. So a player, for example. So in this case, the asteroid is going to be a rigid body. Press that and then create. And we can call this Asteroid. Next, I'm going to take the sprite, and I'm going to drag it down into the asteroid. Next, you can see that the asteroid is located up here on the center of the screen, while the sprite is down here. So we need to move the sprite up there so it's centered on the object. So I'm going to go down on the sprite, go to Transform, and set it to 0. Then I'm going to go up under Rigid Body, and I'm going to press this little icon up here. So what this does is that it makes all the children of this node move with the parent. So when we press something like a child, it's still the parent that we're moving. So I'm going to press that, and now we can see that if I move this around, it is the parent that is moved. If I unpress this and move, then I move the sprite, and the parent is still on the same spot. So the correct way is to have this checked. Next, this rigid body doesn't really do anything, because there is no collider attached to it. So this asteroid can be approximated as a circle. So we're going to add a circle collider to it. So go down, press the asteroid, go to the plus, and then add a collision shape 2D. So the collision shape is it can be approximated as a number of different shapes. So in this case, we're just going to take a regular circle shape 2D. And then we can press this little dot here, and we can resize it. Something like this. And I'm going to name this collider. So now we have added a entity to our scene, and we added a sprite to it and a collider. So if we run this now, you'll see that it starts to fall. Because the default settings for a rigid body is that it's affected by gravity. But in this case, we are in a weightless state. So I'm going to go down under rigid body, and I'm going to change the gravity scale here to 0. So this will make it so that the asteroid doesn't fall. But this isn't very fun because the asteroid isn't moving. Let's add some movement to it just for the fun of it. So I'm going to take the asteroid here, then I'm going to go down under linear, and I'm going to add a velocity here. And I'm going to set the x velocity to 100, and you can see that it starts moving, but it kind of slows down. And the reason for this is that the default settings has dampening. So I'm going to set that to 0 so that it will move endlessly in the same direction. So I can see that it keeps the same speed. Next, this isn't very fun because it's just moving out of the screen. Let's add a twin to it so that they can collide with each other. So I'm going to right click here and then duplicate. Then I take the duplicate and I change the velocity to -100. So it moves in the opposite direction. Then I move this over here. I can move it down a little bit, and we should have a colliding scene. Whoa. So that's great. But you know, in regular asteroids, the asteroid doesn't really slow down that much when they collide. It looks realistic, but that's not the point of this game. We want asteroids to fly all over the place. So let's go up and change the bounds. So we add a bounds of 1 to that, and we have to do it again with the original. And then we can reduce the friction a little bit so that they don't drag so much to each other. Then we play. So now we see that they have a much more bouncy reaction. So it isn't very realistic, but it's fun because this is what the Asteroids game is about. So when the asteroids move out of the screen, they disappear. But in regular asteroids, you remember that asteroids when they move out, they show up again at the other side. And that's one of the cases that it's not realistic, but it's part of the game. So let's add that behavior. And we can do that by adding a script. So go to the original asteroids here, and then we go into Right Prism and select Attach Script. And by default, Godot names this after the node, so we see that the default name is Asteroid.gd, but in this case we want to organize our files. So I'm going to open here, and I'm going to go under the asteroid and save it here instead. And we get a basic template here, where we have a ready function that is doing nothing right now, but this is called when the scene is ready, when it's available in the scene to be able to do stuff. And then we have a commented away function called process, and this is called every frame. So that's where we normally add kind of game logic. So let's make the object wrap around the screen. So we need to be able to access two different things here. First, we need to be able to access the sprite, to be able to figure out when the sprite is out of view. We need to see the size of it to make sure that it doesn't wrap before it's out of view. And then we need to be able to access the viewport to be able to determine the size of the screen. So I'm going to add two variables here. So I'm going to add var sprite and then set it to get node and then sprite. And you can see that Godot helps us here. Something like this. But here is a problem. When this code is invoked, our node might not have been added to the screen yet. You can see that it actually tells us a warning down here that use onReady var sprite instead. So by adding the keyword onReady, we make sure that this initialization isn't performed until after the node has been added to the scene. So that was the sprite. Let's add the viewport. So we create another onReady variable and call this viewport. Next, we take get viewport, and then we want the visible rect. So I'm going to take get the visible rectangle, and I'm just going to take the size to get a vector of the viewport size. You remember I said that this method is called every frame, the func process delta. So normally how you would do is you would uncomment this, and you would write your game logic in here. The problem is we're using a physics system right now. So this would actually be in conflict with the physical forces that's being applied, and it wouldn't work real well. We would get flickering and different kind of bugs by modifying the state in here. So when you're using physics to move the entity around, you have to do it in a function called _integrate forces. So this function is called before the physics is being applied to the entity, so that you can actually change the way the entity behaves. So first we're going to take this state parameter here, and we're going to retrieve the transform of our entity. We take var trans equals state get transform. Next we're going to check if this trans is further to the left than the beginning of the screen. So we take if trans origin, the origin of the transformation, the center position, .x is less than 0. So this would say if we are further to the left than the 0 pixel, the top left position of the screen. And then we say trans origin x plus equals. We increase the x coordinates with the viewport x. So if we are further to the left than the beginning of the screen, move us an entire viewport worth of width to the right. And we can do the same thing else if the first one wasn't true, but we are trans origin x greater than the viewport x. In that case, trans origin x minus equals, we decrease it with viewport x. So this will make sure that we wrap horizontally. But you notice one problem here. We don't take the sprite into consideration here. This would actually make us teleport before we are out of the view, and it would make us appear within the view. So to correct for this, first we need to determine the size of the sprite. So we take var size equals sprite, the variable we retrieved up here, dot texture, dot get size. So this would give us the size of the sprite. But if we take a look at the actual image, we will see that it has a width of 427 pixels, and this is quite wide, and that's because the image is quite high resolution. So this would actually not be very true, because it's the size of the image file and not the size of the image on the screen. So we need to scale it by taking the sprite scale and multiplying it. This would give us the size with the current scale. And then we can say that instead of checking if we are further to the left than 0, we check if we are further to the left than minus size x. And then when we increase it, we want to increase it with viewpoint x plus size x. And this would give us if we are further to the left than the entire size. But since the origin of the sprite is at the center, we can actually take half of this. And then the same thing with the greater than. If we are greater than viewport x plus size x divided by 2. And this works because the division here is being computed before the plus. That's one of the core rules of programming. And then we say decrease it with the viewport x plus size x. So this would wrap us in the horizontal direction. So let's do the same thing with the vertical direction. So we take else if, and then we change all the x's into y's. So here we have retrieved the transform, and then we checked if it's outside of the screen, and in that case we added some values to it. The problem is we haven't applied the transform yet. So to do that, we need to go down here and say state set transform, and then take the new trans. Great. So now if we go back into our scene, we need to attach the script to the second asteroid as well. So we're going to go down here, and then we're going to select node script load. Take the script and save. Now if we press, we see that they wrap around the screen and they can collide again. And the last thing I want to do in this video is that currently we need to copy all of the settings we make to this asteroid to multiple entities, and that's not really how we want to do it, especially not if we want hundreds of asteroids in the same scene. So to solve this, we need to create a subscene. And that's one of the amazing features of Godot. We can take any kind of node here, and then we can right click on them, and then save a branch as scene. And then we can go under asteroid and save it as asteroid. Now you see that it has this little icon here. If we press that, we will open that asteroid in a completely new scene. So we can change these settings, like for example, if we wanted to change the speed of it, we could go down here and we could change the velocity to 200 instead. Save it, and if we go back and just go in here, you will see that it has a velocity of 200. So we can remove this other asteroid we created. So we can select the game, the parent here, select the link icon up here, and then we can take the asteroid and we create an instance of that. And we can change scene specific settings, like we can take one of the asteroids, move it over here, change the velocity of that one to minus, and they will be two separate instances. So that's all for this video. In the next video I'm going to show you how to add a spaceship into this game.